Hi everyone, today we are going to be learning about dividing rational numbers, but when they are decimals. So just like before when we were multiplying decimals, you were able to change those decimals into a fraction. You are still welcome to do that same process, but today I'm also going to show you how to divide when the decimals are just staying decimals. Okay, so let's start with example A. And let's say that I have 4.4 or 4 and 4/10, and I want to divide that by 0.2 or 2/10. I could convert these to fractions and then do keep, change, flip, and multiply straight across. That option is still available to me. Or I can use this as a dividing fractions example. So what I'm going to do is, a dividing decimal. So I'm going to keep these as decimals, and I'm going to show you how to set this problem up. So this first number is the number that we are dividing. So it's going to go into the little house or into the division sign. Then we're going to put divided by 0.2 on the outside. So in order to divide a decimal, if there is a decimal on the outside, we have to get rid of that decimal first. And so the way that we get rid of the decimal is we are going to move it until it looks like a whole number. So here we only have to move it one place before you get a 2. So if we move it one place here on the inside, we also are going to move it one place. And so now we have one place, and then the decimal comes straight up from there. Okay, so you moved it 1, so it's over, up. So here, our new example is 44 divided by 2, and then our little decimal is right there. So now we're going to go through and we are going to solve this problem as though it were 44 divided by 2. So I have 4 divided by 2 is 2. It can go in 2 times, which is 4. So that gives me a 0. I'm going to drop down my 4, and then 2 can go to 4 2 times with 4 left over. I subtract, and then I have 0. So my answer is, to this problem here, it is 22. There is no more moving of the decimal. It could be 22.0 if you wanted to, but 22. So the only movement of the decimal that you need to do when it comes to division is at the very beginning. There's no more putting it back in. If you wanted to work this as fractions, so that this was 4 and 4/10 and divided by 2/10, you could do that if you wanted to. You can multiply and add so that you have 44 over 10 divided by 2 over 10. We're going to keep, change, flip. Keep 44 over 10. Change it to multiplication. And then we're going to flip, so it's 10 over 2. 44 times 10 is 440 divided by 20. So we're going to figure out that this 20 can go in how many times, or we can just remove the zeros like this, and then we get 44 divided by 2, which is what we had here, 44 divided by 2, which is 22. So you choose how you want to solve. I'm going to continue to solve the rest of these by moving the decimal so that you can see how to do that process. If you don't like that, go ahead and convert them into decimal or into fractions first, and then put your answer as a decimal. Okay, So let's go to example B. Example B says to find negative 6.8. So negative 6.8 divided by 3.2. So the first one goes into the symbol. So we have negative 6.8, and we're going to divide that by 3.2. Okay, we know a negative divided by a positive is going to give us a negative. So we can just make sure that we bring our negative sign up. Again, we're looking for a whole number on the outside to do the dividing part. So I'm going to move my decimal point once, which means here I need to move it once, and then I have to move it up. So the new numbers that I am working with, are 68, or negative 68. I'm going to put my negative sign up, divided by 32. I'm now ready to solve this problem. So I have 32. I'm looking to see how many times 32 can go into 68. Well, I know 30 plus 30 is 60, and 2 2s is 4. So this, if I put it in twice, I get 64. And I subtract, so there's 4. I need to put a 0 and drop that down. So now I have 40. 32 can go into 40 one time. So that gives me 32. Now I'm just going to keep subtracting. So 40 minus 32 is 8. 32 cannot go into 8, but it can go into 80. And I know 32, 64, if I go one more time, it's too big. So again, I'm going to put my 2 here. And that gave me 64. And I'm just going to keep going until I can see if I can make it disappear. So for 16, it doesn't go in 16 times. Can it go in 160? Let's think about this. So if I do 32 times, let's say 5, because I know 2 times 5 gives me a 0 at the end. So that's 10, 15, 60, 160. So it can go in 5, and then it all the way disappears. So this problem here, my final answer is negative 2 and 1.125. That's a long problem and a lot of division to make that disappear. Okay, so move your decimal over on the outside, move it on the inside, and then move it straight up. And then do normal division. Okay, applying your rules of negatives and positives. Okay, let's do another problem. I'm going to go ahead and turn my page now since that one took up all of the page. So let's go ahead and look at example C. So example C that we're going to use, I wish they had done one where it was like 2 numbers on the outside, but that's okay. It says 3.6, oh no, I lied. Example C says negative 8.4 divided by negative 3.6. Okay, so right away let's talk about negative times a negative, or a negative divided by a negative. We know we're going to end up with a positive. So now we can ignore those signs until the end when we put we don't need to put a positive sign. Okay, So we have negative 8.4 or 8.4. Let's just put 8.4 in. And that is divided by 3.6. Again, I'm ignoring the symbols, the negative symbols, because I already know I'm just going to end with a positive. This problem, I do need to move my decimal point one place on the outside. If this said 3.66, I would move it 2 places, and then I would need to move my decimal point 2 places here, and then just add in a 0. Okay, so you can move it more than one place. That's important for you to know. And then we're going to move it up. So over, over, up. And then now we are ready to solve. Okay, so we're just going to go ahead and solve this problem. Like it is 36 on the outside and 84 on the inside, and we're going to move our decimal point up. So 84 divided by 36. Well, if we think about our last problem that we just did, we looked at 32 going into 68, and we knew it was twice. That gave us 64, so that's pretty close here. So 6 times 6 is, or 6 times 2, if it goes in twice, is going to give us 12. I think that will work. So let's do 2. And we know that 36 times 2, there's my 12. And that's 72. If I would have gone one more, that would have been too big. Now I'm just going to subtract. So 4 minus 2 is 2. And 8 minus 7 is 1. So I have a remainder of 12. I'm going to add zeros until I can try to get this to disappear. So here's a 0. I'm going to drop that down. It's 120. So now I have 120 divided by 36. So if this one was 72, let's see if we go 36 times 3. That's 18. 3 times 3 is 9. Plus 1 is 10. Okay, if I go one more, it'll be over 120. So I'm going to say I used a 3. And that gave me 108. So 10, 1, so that's 2. Oh my gosh, look, I've got 12 again. So I'm going to add on a 0, and I know that I have 120. It's the same thing. I know I have to use 3 again, and that gives me 108, and that gives me 12, and I'm just going to keep, it's repeating over and over again. I cannot get rid of this 12, so instead what we're going to do is we're going to use this little line on top. This little line tells us that it repeats forever. So our answer is 2 and 33 hundredths. That's our final answer. And it is a positive because a negative divided by a negative is a positive. And we use the little repeating line to show that it is repeating. Okay? All right. Another way that you could have looked at this problem was you could have written it as 84 divided by 36 and looked at it as a fraction, because 84 divided by 36 would give you a fraction. Then you could just divide by 2 and just keep reducing it down until you got to you would end up getting 2 and 1/3, which is the same. 1/3 is a decimal of 0.3 if you multiply that by 10. So this process could work the same as well. Okay, so there's another way to think about that process. All right, we're going to go ahead and do try-its here. All right, so try-it number 1. Try-it number 1 says negative 2.4 divided by 3.2. And then we have try it number 2. Try it number 2. Is negative 6 divided by negative 1.1. Okay, again, you can use fractions or you can use decimals, your choice. Okay, go ahead and hit pause right now so you don't hear me solving, and then when you're ready, go ahead and hit play. So I'm going to move my decimal once over. So I have 24 divided by 32. Again, this is a negative, so I'm going to put my negative right there. I could also look at this as negative 24 over 32 and divide that way if you want to make it a fraction and then reduce it down. Totally your choice. So I'm going to look at this. I know that as soon as I moved my decimal over to the end, I need to move it up. So 24 cannot be divided by 32. So what I need to do is I need to add on a 0 and think about this as 240. So how many times can 240 be divided by 32? So it can go in, let's think. Let's look back at we did a 3.2 here, and 5 was 160. So let's look at what 7 would be. So if I had 32 times 7, that's 14, and it's 21, 22. Ooh, look at that. That's pretty close. Okay, so 7, and that gives us 224. So that's 16, and I'm going to add another 0. And 32 into 160, I'm going to look back because I know we did it over here, and that was 5 times, and that gave us 160. So 0.75 or negative 0.75. If you wanted to look at this as 24 divided by 32, negative 24 divided by 32 like a fraction, and then you could reduce this in half. That would give you 12 over, what's 32 in half? 32 divided by 2. I don't know why my brain's not working right now. 16 over 16, and then cut that in half again. That would give you 6 over 8. Cut it in half again. That would give you 3 over 4, and we know 3 out of 4 quarters is the same thing as 0.75 or 75 cents. So you can use this method if you want and just cut them in half over and over and over again, or you can move your decimals, your choice. Okay? All right, let's look at this problem. This one we have a whole number. So in our whole number, we have, let's use a different color. We have this whole number of 6. A negative divided by a negative is going to give us a positive, so I'm going to ignore that sign. I have 6 divided by 1.1. I need to move my decimal once. There is no decimal, so I'm going to put it at the end and move it once and fill in the little hole. So now I have 60 divided by 11. Well, I know that 6 times 11 is 66, so that's not going to work. So instead, I am going to do, oh, whoops, there's my decimal. I am going to do, no, that's not right. Sorry, my decimal goes here. Okay, so instead, I'm going to do 5. So it goes in 5 times. And that is, I'm going to rewrite this. 6 divided by 11. My decimal was here. I moved it once, so I need to move it once here. Fill in, it goes up. There we go. 5 times 11 is 55. All right. That gives me 5 left over. I'm going to put a 0, drop it down. This has to be a 4, which gives me 44. Subtract. So 6. I then get a 0. Oh my gosh, look, I'm back to 6 again. So I'm back to 6, 60, and that was a 5. And that gave me 55. So like I'm on repeat right now, like a really bad record player on repeat. So my answer is going to be 5.45 with the little repeater. Okay, so that is my final answer here. It's repeating. It's never going to go away. Okay, you could have also thought about this one as 60 divided by 11 and done it as fractions. All right, go ahead and answer your essential question. How do we solve rational numbers with decimals? And then put your level of understanding out to the side. And then when you are ready, you may come back to the Google Meet and ask for help, or you can go ahead and do your practice work. As always, I appreciate all of your hard work and effort, and make it a great day.